Hi, so today there's actually gonna be something different. Unfortunately, due to renovation, I cannot be at the university, so I'm gonna just give you some comments to the notes that I prepared for you. Okay, and look, today what we are going to do is inflation and unemployment model, so the Phillips curve, but this time we are going to do it in discrete time. Okay, so let's go back for a second to what we learned. Look, this system of three simultaneous equations is what we did in a continuous time. Again, P stands for inflation, pi is expected inflation, U is unemployment, T is productivity growth, and M is growth rate of money supply. Look, all we need to do at this moment is to translate this model into a model in discrete time. And look, it's actually quite easy. Let's do it equation by equation. P as a function of time, we simply change into pt. Alpha stays alpha, t stays t, beta stays beta. Of course, here we have minus because remember, this is a Phillips relation where here we have Phillips relation augmented by expectations. This is why we have this G times expected inflation term. Okay, and of course, U changes into UT, pi changes into pi t. Now, what is going to happen in case of derivatives? Look, derivatives, in case of difference equations, we simply substitute with differences. So here we have basically, instead of derivative of expected inflation over time, so change of expected inflation over time, we have this change expressed simply in form of delta. So it's, in our case, this is pi t plus 1 minus pi t. The rest stays the same. We have some, and of course, alpha, beta, and t are positive parameters, and g is somewhere between 0 and 1 without 0, but if we would have that g is exactly 1, we would have this case of perfectly vertical Phillips curve that you know from macroeconomics. Okay, and here we are again assuming that expected inflation is a function of the difference between actual inflation and expected inflation. And the bigger is the actual inflation, so the bigger is the difference, of course, the more the people adjust their expectations upwards. So if inflation in year T is bigger than expected inflation in year T, the households, economic agents generally will expect higher inflation, so delta pi will be positive. And again, the last equation is for monetary policy and impact of monetary policy on unemployment. Here we have delta unemployment, ut plus 1 minus ut, and it's equal to negative k, again positive parameter, where here we have real money growth, where m denotes nominal money growth, while pt plus 1 denotes increase in price level. You might be wondering why we do not use it here, pt. Look, actually, we would end up with exactly the same conclusions at the end of the model, but this model is actually pretty heavy to solve, and in this way, it actually saves us some steps. Okay, so this is exactly the same model setup as we had in case of differential equations. So this is a Phillips curve model, basically. Now, what are we getting from it? Oh, sorry. No. Okay, so look, we need to do the same thing we've done before. So we're going to condense all three equations into one. How we're going to do it? We're going to make one difference equation, this time in price level. And we're simply going to do it by calculating the difference, PT. So PT plus 1 minus PT. Now, PT plus 1 is simply alpha minus t beta ut plus 1. So we just moved all the subscript plus by 1. And now we calculate the difference. Look, because we're differentiating this, we are moving from first differences that we had in the previous equation into second differences. And we want to deal with the second order difference equation. And look, what we do over here is now we substitute PT plus 1 and we subtract from it PT, just PT. You see that alpha t all cancel each other out. And if we organize everything, so here we have delta u, here we have delta pi with appropriate coefficients. We basically just use, at this moment we just organized those variables. And look, now, because we have this ut plus 1 minus ut, we can go back to the previous slide, previous sheet, and we've got that we can substitute the third relation. And of course, instead of delta pi, so pi t plus 1 minus pi t, we can substitute the second equation. And when we do it, we will obtain this relationship that delta pt, so, is equal to this. And look, at this moment, we already condensed all the information from three equations into one. So, but look, this is not something we can work with. What we need to do is that we need to transform this equation into equation in only variable p alone. Okay, and we need to, in order to do it, we need to use a couple of tricks. The first trick is what you see over here. Look, again, look, out of this equation, if I move all these three terms to the other hand side, we will get that g pi t is equal to pt minus alpha minus t plus beta ut. Okay, and look, here, what we see over here is the same equation as here, but already we multiplied everything out from the last parenthesis. Okay, and why did we do it? Because look, now I can use this component, this last component, and I can substitute all of this over here, right? Remember that in this case, we already had g pi t, so only thing that goes in front of everything is j. Okay, so now what do we do next? Look, then what we do is we organize everything here. So we put all the, let's just say, endogenous variables, so p, u, and that's it, because we don't have pi anymore, on the left hand side of the equation. And we organize everything. And look, I can take now this equation, move all the subscripts by 1, and of course, nothing will change over here. And now there is this troublesome part where you can, when it's the easiest to make a mistake. This is why I denoted it like that. Look, what I did over here is now that I'm calculating the difference between this. It's like 2 minus 1. So this part, left hand side of the equation minus of equation 2 minus left hand side of equation 1 is equal to right hand side of the equation 2 minus right hand side of the equation 1. Okay, and let's start with the left side. And look, again, what we need to do is to put everything down. We see that we can collect all the terms. And, and again, over here, we can substitute the third equation from the model setup. And now, once we do it, we collect everything. We are arriving finally at this result that you see over here. This is very troublesome. It's really easy to make a mistake. You can see that I needed to make a correction here because it's not very complicated. You just need to remember the trick. Like right hand side of the equation, very easy. Why? Look, because when those two terms are identical, so we end up with 0. And now look, this means that left hand side is equal to right hand side. So all that we've got over here is simply equal to 0. Look, the only component without p is this one. So we move it to the other hand side of the equation. And now look, the only thing left to make it into the form that we know is to divide both sides by 1 over beta k, which is the coefficient on pt plus 2. And look, now we have a second order difference equation. And here pt is missing. Yeah, here should be pt. Please remember pt should be over here. I'll fix it soon. We got second order difference equation, and we can solve it exactly the same way as we solved every other equation before. Okay, so we need to find the time path. And as before, we need to start with particular solution, so our equilibrium. And look, so I use here simply the formula C1 plus A over 1 plus A1 plus A2. This is our C. And this thing over here, this horrible expression, is A1 plus A1 plus A2. Okay, I'm keeping this part the same way, and I'm changing 1 into 1 plus beta k. So everything now is in common denominator. I can just add everything up. As you see, everything cancels each other out here. And what I'm doing next is that because we are dividing, so I'm reversing numerator and denominator in such a way that multiplication division. I'm sorry, I got an email, but let's go back to this. And as you see, now we can cancel even more parts cancel each other out, and we end up with m. And look, this is exactly the same solution that we got in the differential equations model. So we see that in the long run, actually, Monet's growth rate of price level depends solely on growth rate of money supply. Okay, so now let's go to complementary function. Look, this big part is our A1 square, and this is for A2. And we of course know that 1 plus beta k, which are both positive parameters, this is definitely bigger than 1. So look, we can have 3 different possible cases here, and those cases depend on whether though this or this expression, which one is bigger, or maybe they are equal to. And of course, to make things simpler, we can divide both sides by 1 plus beta k. And okay, look, let's consider all these cases one by one. Case number 1. So what if alpha 1 square is bigger than 4a2? Well, then we will have case 1 distinct roots. b1 plus b2, which we remember is equal to negative a1, is equal to this. And look, if I'm gonna calculate this all out, I'm gonna end up with this plus 1 minus j. This is some fraction between well, this is some number, not exactly, it can be technically speaking above 1, but it's really unlikely. But well, it definitely cannot be bigger than 2 because okay, doesn't matter, but this is a positive number. And look, again from this, then here we have 1 minus j, which is somewhere between 0 and 1. So definitely sum of 2 positive numbers bigger than 0. And here, b1 times b2 is equal to a2, which is this much. And look, here we clearly see that here is 1. We subtract here, 1 minus g is somewhere between 0 and 1. So j times the number between 0 and 1 also is a number between 0 and 1. So we get from this that this must be somewhere between 0 and 1. And this is clearly a positive number. And look, because of this 2, we get, if the sum of two numbers is positive and the product of them is positive, they definitely need to be positive, right? Now, we calculate the same expressions as with Samuelson model. So 1 minus b1, 1 minus b2. And so we substitute here negative a1, a2. And upon some calculations, we arrive at this. And look, this again must be positive. So look, we know that numbers cannot be both negative. So we see that, but can they be equal to 1? Look, if they would be equal to 1, this would be 0. Impossible. Can one of them be negative? Well, again, impossible. So it means that, and of course, if they would be both bigger than 1, then this would have to be bigger than 1, which is impossible. So look, we get that the only possibility over here is that both of them need to be between 0 and 1, which again guarantees to us both roots are between 0 and 1. This guarantees that we will not have oscillation and we will have convergence. Okay, and finally, case number 2, repeated roots. So now a1 square is equal to 4a1. Now we have just one solution, b equal to negative a1 over 2. This is equal to this much. And this positive, positive, somewhere between 0 and 1, positive, divided by positive, definitely a positive number. And look, if I'm going to take it to the power of 2, this must be equal to a2, so this much. This is between 0 and 1 again. And look, if this is between 0 and 1, two the same numbers, if the numbers are the same, well, if we have one number and we multiply it by another number, and we get and we know that they are positive, and they give you a number between 0 and 1, there must be between 0 and 1. Again, we have stable equilibrium and convergence, no oscillation. And finally, case of complex roots, which is actually the easiest here because r is simply equal to square root of a2, which is equal to square root of this. So a number between 0 and 1. Again, we can be sure that this is a number that is somewhere between 0 and 1. So again, we can be sure that here we will have stable equilibrium. Okay, so what do we have learned from this model? Look, this model is also showing us that in equilibrium, this time price level, inflation, not expected inflation like we did before, is simply equal in the long run to money growth, which makes perfect sense. You learned about it in macroeconomics many times. But we also see from this model that regardless of the parameters, exact values of the parameters here, we will always have a stable equilibrium and convergence. Okay, thank you for your attention. See you in the next video.